what you're talking is that 342 to 342. Truffle company makes high quality handmade chocolate truffles, which it sells to a local retailer. All chocolates are made in batches of 16 to fit the standard boxes supplied by the retailer. The standard cost of labor for each batch is $6, and the standard labor time for each batch is half an hour. In November, Travel Company had budgeted production of 24,000 batches. Actual production was 2,500. 12,000 labor hours were used to complete the work, and there was no idle time. All workers were paid for their actual hours worked. The actual total labor cost for November was $136,800. The production manager at Travel Company has no input into the budgeting process. At the end of October, the managing director decided to hold a meeting and offer staff the choice of either accepting a 5% pay cut or facing a certain number of redundancies. All staff subsequently agreed to accept a 5% pay cut with immediate effect. At the same time, the retailer requested that truffles be made slightly softer. This change was implemented immediately and made the chocolates more difficult to ship. When recipe changes such as these are made, it takes time before the workers become used to working with the new ingredients mix, making the process 20% slower for at least the first month of the new operation. The standard costing system is only updated once a year in June, and no changes are ever made to the system outside this. So they want us to calculate the following variances for truffle. The last question you're doing of this nature: labor rate planning variance, labor rate operational variance, labor efficiency planning variance, labor efficiency operational OTM variance. So you see, the first thing we shall do is just to do a small table, because it has got planning and operational variances. We need to do a small table where basically we shall be able to show the original, the revised, and the actual. Are you able to do that table for me, my good students? Are you able to do that table for me, my students? Are you able to do that table for me? Because they've mentioned the word planning operational, then you need to give us original, column for revised, column for actual. But strictly speaking here, they're only looking at what we call labor. It was quite a tricky question, but we should be able to handle it very well. We should be able to handle it very well. Should be able to handle it very well. All right. So then what are we given, ladies and gentlemen, here? So what we are given here is labor. So we need this table. So we need this table where we capture the original, in this case here, budgets. Then we have the revised. Then we have the revised. Then we have the actual. Those three. This thing is very bright. All right. So remember, this is labor. So we have our labor cost. We have our labor cost. So what have they told us about labor cost? Let's begin from the beginning. What have they told us about labor cost? So they've told us here that the standard labor cost for each batch is 6 per hour. For each batch is 6 per batch. So the standard labor cost is 6 per batch. Great. What else have they told us? And the standard labor time for each batch is half an hour. Is half an hour. So you see, what I want is for each batch, hours, in this case here, times rate per hour. Times rate per hour. To be able to get, in this case, the labor cost, we take the hours times rate per hour. And they have told us that the total labor cost per batch is 6. And each batch, they have told us, takes half an hour. Each batch takes half an hour. So in this case here, each batch is half an hour. So half an hour times a rate which we do not know. Call this rate X. Should be equal, in this case here, to this 6 here. Meaning that our X will be 6 divided by 0.5, which will give me 12. Which will give me 12. Which will give me 12. So they are paying $12 per what year? Per hour. They are paying $12 per hour. Remember, the 6 is per batch. What they've told us here is that this 6 is per batch. This 6, they've told us here that this 6, if you see this, all chocolates are made in batches of 16 to fit the standard boxes supplied by the retailer. The standard cost of labor for each batch is 6. Labor cost per batch is 6. And the standard labor time for each batch is a half an hour. So remember here, we are doing our accounting on the basis of what year? Batches. So in this case here, we have here, this is cost per batch. Cost per batch, which in this case here is 6. And you're saying, then how do we generally get this labor cost? We normally take the hours worked times rate per hour. And to make this one batch, we need 0.5 hours. And therefore, the rate per batch has not been given. But we know that this times X should be equal to 6. Therefore, X alone will be 6 divided by 0.5, which will give me 12 like that. Which will give me 12 like that. All right. So in this case here, we know that our X then is 12. So then we continue with it. So what have they told us ahead here? What they've told us ahead here is this. They've told us in November, travel company had budgeted production of 24,000 batches. Actual production was only 2,500. 12,000 labor hours were used to complete the work, and there was no idle time. So then the actual hours here were 12,000. I'm looking at actual hours. So the actual hours here were 12,000. The actual hours here were 12,000 hours. 12,000 hours. 12,000 hours. 12,000 hours. I'm putting that under actual information. 12,000 hours. And then they're telling us, and there was no idle time. All workers were paid for their actual hours worked. The actual total labor cost is 136,800. They've given me the total cost. Total actual labor cost. Total actual labor cost is 138,600. Total actual labor cost is 138,600. I'm putting that on the actual. 136,800 actually. 136,800. 136,800 actually. And therefore, in this case here, the actual rate will be equal to the actual labor cost of 136,800. We divide this by 4,000 hours. We don't have to get the division. We don't have to get the division. So this will be the actual rate in terms of dollars per hour. In terms of dollars per hour. It shall make sense. It shall make sense. It shall make sense. So then what are they telling us next here? What they're telling us next is this. At the end of October, the managing director decided to hold a meeting and offer staff the choice of either accepting a 5% pay cut or facing a certain number of redundancies. All staff subsequently agreed to accept the 5% pay cut with immediate effect. So remember, we had set in this case here our budget at the beginning of November, whatever, earlier on, we had set our original budget. But we're told in between here, things changed. Workers accepted a lower rate. So in this case here, a lower rate, so we have the reduced rate per hour. Reduced rate per hour. So the reduced rate per hour, In this case here will be equal to, remember we're paying them as 12, this 12 here per hour. And they have accepted a 5% pay cut. So in this case, it will be 12 times 95%. Are you able to give me this? 12 times 95%. Are you able to give me this figure? Together gives me 11.4. So $11.4 per hour. I'm just going to shillings, but these are ACC questions, dollars per hour. So that these workers in between accepted a reduction. So then we must revise our standard. We must revise our standard to reflect what is happening on the ground. Reflect what is happening on the ground. And then what else are they telling us, ladies and gentlemen? What else are they telling us, ladies and gentlemen? What else they are telling us is this. At the same time, the retailer requested that the truffles be made slightly softer. It's like the queen cakes. The queen cakes. This change was implemented immediately and made the chocolates or chocolates more difficult to shape. When recipe changes such as these are made, it takes time before the workers become used to working. They become used to working with the new ingredients mix, making the process 20% slower for at least the first month of the new operation. Remember, initially, the standard was these guys were taking 0.5 hours. That was the original. But now they're going to work, much slower, and therefore the time is going to increase as well. The new time here, the new time. So in this case, the new time to make this, it will be 0.5 hours times 120%. Because you see, it's increasing by 20%. Over and above the normal 100, this time will go up by 20%. Because these guys are going to become slow. When they become slow, they take more time. When they are slow, they take more time. When they are slow, they take more time. So this gives me 6 hours. 6 hours. So basically, my revised labor cost, will be 6 hours. 6 hours will be 6 hours times 11.4. Is it 6 hours or 0.6? It should be 0.6. Check. Should be 0.6. So it should be 0.6 times 11.4. 0.6 times 11.4. So now remember the revised labor cost here was, or rather the labor cost here was 6. Now the revised labor cost here will be what here, somebody? The revised labor cost will be 6.8. This will be 6.8. Thank you very much. Now then after I've been able to do this very well, I will be able to, in this case here, come here and ascertain the labor rate variance. So how do I get labor rate variance? To get labor rate variance, we normally take the standard rate minus the actual rate. And then we multiply this with the actual hours. But now remember, here they want us to do what you have to give them, what we are calling the planning. They're calling the planning. So under planning, we normally compare what versus what. Under planning, we normally compare what versus what. Can somebody remind us? We normally compare two things, planning variance. Planning variance, we normally do some comparisons. We normally compare what versus what. Please remind me. Please remind me. Original versus what here? Revised. So remember planning, this original budget, this is revised budget. So planning, we normally compare just budgets. So this should be original, this should be revised. So here we are writing on top, revised. We don't change this, I left line revised there. So then, are you able to see the standard rate, the original? Remember, this is original. Are you able to see the original standard rate? So the original standard rate per hour, remember this is a rate per hour. The original standard rate per hour, which is this level, is 12. Minus the revised rate per hour. The revised rate per hour, you guys gave me 11.4. 11.4. Remember, this comparison only happens in brackets. Otherwise, here when they say actual, you must go to the actual. The actual hours that we have here, these were the actual hours. The actual hours that we have here were 12,000. The actual hours we have there are 12,000. The actual hours we have there are 12,000. So then are you able to give me this labor rate variance, somebody? And all of us must participate. This model is here to help you. This model is here to help you. All of us must participate. These are very serious questions. 7,200. Is it hours or, this money? It's a variance. So we should talk of what here? Favorable figure. If it's positive, yes. 7,200, favorable. Can I challenge you, my good students? Can I challenge you, my good students? For the comparison, the comparison. Remember comparison? Normally, we do this, we have this. This and this is what we call planning. And then this and this is what we call operational variances. Operational variances. So these are planning variances. Planning variances. Chugo must have missed maybe a class or something. All right. So in this case here, planning variances, we compare between original versus revised. When we talk of labor rate variance, it is the standard rate per hour minus actual rate. But remember when it's planning, then this will be original rate, this original rate minus revised rate, So the original rate here per hour is not this 6 is per much. It is 12 per hour. Minus, in this case, the revised rate. The revised rate per hour is this one, 11.4. Into outside, then we have 12,000. Remember, it is well within here. When we are inside here is when we talk about planning it is. But outside, we shall always talk about what here actual things. Actual. I hope that is helpful, and I will be able to give you some video. You also make further reference to this. So I want you to look at this part here, where they want us. So this is yours. So I want you to look at this part, where they want us to give them the labor rate, but operational this time round. Labor rate, but operational. Let's try yourselves to see. Labor rate, but operational. Where operational we are comparing revised versus actual. Let me give you 2 minutes.
We get 24.3 grams. 3.
Let me get these one here. So is there anybody who is getting like 0? Is anybody who is getting like 0? 0, yes, 0. Because you can see, like the first one, if you look at the answer, the first one is 7,200 favorable. Second one is what here? 0. Second one is 0. So then what I will do here is really very simple. This is a very simple thing I can show you. What I will come and do here. What I come and do here.
You get 14.8 grams.
So we have labor rate. Yes, like operational. So we'll still write the normal way. We know labor rate variance is difference between 2 rates. So we have the standard rate minus the actual. But now outside here we have the actual hours. Now remember operations, we are comparing revised versus actual inside here. So this should be revised. This is actual. So the revised standard rate per hour is 11.5 minus actual rate. Actual rate per hour is there. It's 1,368 divided by 12,000. Then we come here and multiply this with the actual hours. So actual hours we have them here. They are 12,000. I believe if you do it very well, then you should be able to get a 0, which is a neutral number, not favorable, not adverse. Not favorable, not adverse. Thank you, Juliana. So Juliana is already giving a first question, although you can do it directly in the calculator. You say open brackets 11.4 minus this divided by this, you close times 40%. You'll be able to get a 0. You'll be able to get a 0 there. You'll be able to get a 0 there. So is that okay, ladies and gentlemen? Hopefully somehow you are able to follow, somehow you will overcome. Now, let me try you on this next one. Oh, this is the answer. But again, I can also start with the answer. So I want you guys to see whether the labor efficiency planning variance, whether there is anybody who will be able to get this 24,600 bus. Let's see. Let's see labor efficiency planning variance. The next question they want us to give them is called labor efficiency planning variance. This one here. This one here. They are calling it labor efficiency planning variance. Labor efficiency planning variance. Can I give you 2 minutes to try? You see whether you'll be able to get that answer that I told you. Labor efficiency variance planning. Labor efficiency variance, but planning. So labor efficiency variance, but planning. Now, one thing that I know about labor efficiency variance, I know the most efficient people on earth go to Britain, go to America. It is these Indians. Mr. Shah. So we have in this case here Shah, and then outside here, of course, we're going to monetize this by putting their standard rate. By putting the standard rate like that. So if you're writing this, remember SH stands for standard hours for actual production. Standard hours for actual production. So then again, remember in planning, we are comparing regional versus revised. We're comparing original versus revised. So you can see from here, the standard hours are how many? 0.5. So 0.5 hours, this is per unit, times the number of units that were actually produced. Is there anybody who is able to see the number of units that were actually produced in this question? Is there anybody who is able to see the number of raffles in terms of batches that were actually produced? You can see the actual production here was only 2,500 batches. 2,500 batches. So times 2,500 times 2,500. That's 2,500. Minus, in this case here, actual. But remember, it is revised actual. So where is the revised actual hours? Where are the revised? The revised hours are here. You guys are giving me the hours. They were 0.6 hours. The revised, you know, this is 0.6 a batch. So it will be 0.6 times 24,500 as well. This is 24,500. Remember, it is standard hours for actual production. Or it is 20, not 24. Sorry. It is 2,500, yes. It is 2,500. So 2,500. So this is 2,500. 2,500. And then outside here, then we have the standard rate. So which standard rate shall we use? It is standard that is outside. We should always use the very original. The original standard rate per hour, you guys are given me a theory of 12. So what are we able to get outside there, my friends? What are we able to get outside here, my friends? 24,600 plus. 600 was. I hope this answer is given there in the book. I hope this answer given there in the book. So is asking, not actual standard rate. Remember here, whenever it is standard rate, it can never be actual. Standard, we must always go back to the budget. What we realize trouble is that if, for example, it is quantities that are outside, quantities like, for example, kilograms, they will be actual, like actual hours outside. Now we have actual hours outside. But whenever it comes to money, standard money, standard rate, if it's money, it has to be standard rate. You must go back to the original. You must go back to the original. You must go back to the original. So it will be the standard. You must go back to the original.
You get 8.4.
So we have here, you can see this 24,600 adverse. Thank you. Then are you able to do for me the labor efficiency, but now this time around operational, and then we see whether you guys will be able to get 300 favorable. I don't know, 3,600 favorable in terms of dollars, 3,600 favorable in terms of dollars. Let me give you 1 minute. Let me give you 1 minute. Give you 1 minute. Labor efficiency variance, but this time around what here? Labor efficiency variance, but this time around operation. No, this time around operation. Labor efficiency variance, this time around operation. Let's try this. Labor efficiency variance, this time around operation. So in the interest of time, it is still a labor efficiency variance. So we have here standard variance. And we have standard what here. Now remember operations, we are looking at the revised here, right? So the revised, I can see the revised here, the hours were, I've forgotten that there was 0.6. But you see this 0.6 is per batch. It is per batch. So times 2,500. It's 2,500 minus actual hours. So now you're taking this because it's operational. Actual hours are 12,000. Here you can easily confuse and say, this standard rate now should be which somebody may take this 11.4 bar because they'll tell you that you're comparing this. Outside here, we have got nothing like planning, we've got nothing like operation. Outside here, when they say standard, it has to be original. It has to be original. You must go back to the mother. But we have the comparisons between revised and original, revised and actual, it is in brackets. But outside when they say standard rate, they're very original, very original. So the standard rate was 12. So are you able to give me that answer? Already, Juliana has that 600 favorable. The one that was given there, 600 favorable. Great. Thank you so much. So please, I think now this concept of planning and operational, you guys will be able to fight with a question. If they give us this kind of a question, you guys will be able to fight with it serious. You may not get all the marks, but you should not get below 50%. Because I can assure you this is an area they bring, like most of the candidates in the whole country will not be able to pin this question down. You guys will be ahead of them by far. All right. Now then, your permission, I'll be able to note the answer. So please, you'll be able to read that one on the performance of the manager. Of course, where there are favorable variances, you know he has performed well. So sure that you'll handle very well. The other thing that I'm almost certain that you will be able to get very easily in your exams, and I'm so sure now you have some knowledge. Let me just make it, completize it by repeating. It is this concept of ABC, activity-based costing. And I would want us to use this question, which is question number 3 on page number 340. Question number 3 on page number 340. So we are told here, B brick by brick is a business which provides a range of building services to the public. Recently, they have been asked to quote for a garage conversions and extensions to properties, EX, and have found that they are winning fewer garage conversions contracts than expected. BBB has a policy to price all jobs at budgeted total cost plus 50%. Overheads are currently absorbed on labor hour basis, resulting in a budgeted total cost of 11,000 for each GC and 2,500 for each EX. Consequently, the products are priced at 16,500 and 3,750 respectively. The company is considering moving to an activity-based costing approach. We are provided with the following data. They have given us here the activity drivers. You can see the overhead category, etc., total number of activities per year. A typical GC costs 3,500 materials and takes 300 labor hours to complete. A GC requires only one site visit by a supervisor and needs only one planning document to be raised. The typical X costs 8,000 materials and takes 500 hours to complete. An X requires 6 site visits and 5 planning documents. In all cases, labor is paid at 15 per hour. So they want us to calculate the cost and the product price of a GC and an X using ABC. With CPA, they give you more than 10 marks there. They'll give you more than 10 marks there. All right. So I'm going to do just part A alone, where I would want to see whether there is anybody who would have gone ahead in this case here to correctly lay down the ABC structure, the ABC table. The ABC table. 1 minute. All right, at least 3 responses. Now I can do it. 3 responses. Okay. Who has managed to do this question? Do it. No, this is a very easy one, honestly, Juliana. See, this is the easiest, but let me do it. You see, here, they have given us the supervisors, and you can see the site visits. Site visits, in this case here, are the activity driver. Is activity driver. Planning documents for planners. Property related is labor hours. So no problem. So first of all, I'll analyze my activity drivers. So I have 3 of them. My activity drivers, I have 3 of them. My activity drivers, I have 3 of them. So I have activity drivers. Or activity drivers, what we also call cost drivers. The cost drivers are 3. The first one is site visits. Site visits. Second one is planning documents. Planning documents. Planning documents. And then we have the last one, the labor hours. We have the labor hours. Then remember, we have got 2 products here, right? We have the GC. We have the GC. And then we have what they are calling EX. DX. So for site visits, what am I able to see? Site visits total are 500, no problem. But down here, they've split this down here. They're telling me a GC requires only 1 site visit. So GC requires only 1 site visit. GC requires only 1 site visit. A GC requires only 1 site visit by a supervisor, and it is only 1 planning document. 1 planning document. 1 planning document. 1 planning document. The typical EX costs 8,000 in materials and takes 500 hours to complete. And EX requires 6 site visits and 5 planning. So 6 visits and 5 planning documents. How about 500 hours to complete? So 500 hours to complete, 500 hours to complete. And then labor for GC. Is there somebody who is able to see labor for GC? $500 is for GC. There's something missing there. No, let's just read it very well. A typical GC costs at 500 materials and takes 300. So GC is 300. 300. All right. Now everything is in place. Everything is in place. Okay. So you see, they're not telling you like site visits per unit. No. So here I will not involve number of units. So I know that the total here should be 7. Total here. This should be 7. This should be what here 6. This should be 800. So in terms of fractions, if you wish, you can talk of 1/7 etc. So once I've been able to understand in this case here that my cost drivers, it will be very good for me to come here and do the overhead analysis. Overhead analysis, stroke apportionment. Overhead analysis, stroke apportionment. So we have 3 overhead items. The 3 overhead items are which ones here? We have 3 overhead items. So we have supervisors. We have supervisors. Apart from supervisors, we have planners. Apart from planners, we have property related. So supervisors, have they given me the cost driver? Yes. They've told me supervisors, it is a site visit. It's a site visit, of which I can see site visit is 1:6, giving me 7 in total. And then are we able to see the next? The next one is planners. For planners, they have told me it is documents. And documents, I can vividly see it is 1 to 5. Okay, supervisors, planners, and then we have a property related. So we have here property related. So property related, they're talking about hours. And the hours are 300 to 500, giving us 800. And the expenses are what here? You can see the supervisory is 90,000. Supervisory is 90,000. Then we have planners. Planners is 70,000. Planners is 70,000. Then we have property related, which is 240,000. Then we have got our two products, GC, and U, and X. GC and X. GC and X, like that. Yeah. Now I'm so sure you guys can do the subdivision very fast. Are you able to subdivide yourselves? Are you able to subdivide yourselves now? Or the supervisors, site visits 1 to 6. So like the first GC will be 1/7. 1/7 times that 90,000. A funny figure. 1/7 times 90,000. Like if it is X, it will be 6/7 times 90,000. Give me like whole numbers to make this thing as easy as possible. So like what I can do is to take what Juliana has given me, 128.57. That's the whole number. 128.57, a whole number, to make it easier. Then in this case here, how about for X? Please try to give me the answers. This is very good for you. You need this.
Okay. First, I took 64.0 minus 38 to get the mass of samples.
77,143.
Then I took the mass of the body, which was 38.
77,143. How about in this case here, these planners? So the planners, what do we do for planners? It is 1/6 times 70,000. Give me a figure.
Then I took
34/11,667.
which was the density.
Then we have 5/6 times 70,000. What figure are we getting there? 58,333. How about property related? Are you able to subdivide yourselves? Mine is really hidden. Are you able to subdivide yourselves? Mine is really hidden. So this one here gives me 90,000. So 3/8. So this one here gives me 90,000. versus what here? 5/8 times 240,000. That gives me what figure somebody here? 150,000. That gives me 150,000. 150,000. Like that.
Okay, thank you.
150,000. Mhm. The answer is a little bit different. Oh, I have to check later and see what happened because these are not things we should get any mix-ups, because you see the figures they have given us here, they're not like figures per unit, where in this case we shall look at number of units to multiply. They're supposed to be totality by themselves. They're supposed to be totality by themselves, but allow me to look at this question later and then I'll be able to redo it tomorrow. I think there must be an area, either information we skipped, or in this case here, they could also be wrong. At times they are wrong. At times they are wrong. But generally, the thing is, if they give us like site visits per unit, then you take this figure times the number of you to get totals. I can see they're using different values, but allow me to look at that later. Allow me to look at this later. Sorry for that. So you can't continue with this because I've seen the figures are what here. Figures are different there, which is very good because I'm not that kind of a person who does not believe in excellence. It should never be excellent. Only God is excellent. Now, there is one question that I want us to do pretty fast, which is very good for all of us. Please take this question seriously. It's called HC question. HC. Yeah, it's on page number 66. Page number 66, HC. Yeah, great. Page number 66, 49, question number 49. Page number 66. Once you guys get this question of learning curves, please mention their Y for yes. Mention their Y for yes.
So the mass will be
Mention the Y for yes. Great. So then this is also a very intense question. And the other one I've seen where we went wrong. It is as we are wrong. Just remember something. I'll be able to correct it right now. Now, you can see here, Henry Company provides skilled labor to the building trade. They have recently been asked by a builder to bid for a kitchen fitting contract for a new development of 600 identical apartments. HC has not worked for this builder before. Cost information for the new contract is as follows. Labor for the contract is available. HC expects that the first kitchen will take 24 man-hours to fit, but then after, the time taken will be subject to a 95% learning rate. After 200 kitchens are fitted, the learning rate will stop, and then the time taken for the 200th kitchen will be the time taken for all the remaining kitchens. Labor costs 15 per hour. Overheads are absorbed on a labor hour basis. HC has collected overhead information for the last 4 months, and this is shown below. So HC normally works around 120 labor hours. HC uses a high-low method to analyze overheads. The learning curve has been given there. So they want us to calculate the total cost, including all overheads for HC that it can use as a basis for the bid for the new apartment contract, 10 months. So of course, these learning curves, whenever they talk about learning curves, there are those things that we must remember. Learning curve, first of all, it is the equation. The learning curve equation is very, very important. Our y should be equal to ax raised to power b plus 1. If you remember, A is the time taken to make the first unit. A is the time taken to make the first unit, which in this question they have given to us. Is there somebody who is able to give me that time taken to make the first unit? Somebody who is able to tell us the time taken to make the very first unit.
Okay.
Given the question, no trick here, no trick at all in this question, no trick at all. So you can see here, the time taken to make the very first, 24 hours. I expect that the first kitchen will take 24 hours. So 24 hours. So A is 24 hours. And then if you remember, B is what we call the learning index. Learning index. And to get this learning index, we normally take log R divided by log 2. Log R divided by log 2. And they've told us here R is the learning rate, and it has been given to us as 95%. So then this one will be log 0.95 over log 2. Is there somebody who is able to give me this figure from their calculators? Log 0.95 divided by log 2. It is already given in the question, but it's good to also know how to calculate it. So Juliana is giving me a figure of 0.07. I hope all of us are able to see where log 0.95 is. Log 0.95 over log 2. So minus 0.078. So that is our B. But you see the formula, we need B plus 1. So we have here B plus 1, which will be minus 0.074 plus 1, which will end up giving us what figure sample here? 0.926. So this is 0.926. Yeah. So therefore the equation. So the equation will be y, which will be equal to A 24 x raised to b plus 1. That is very important. You get a mark there. But remember that this is not going to be applied indefinitely. This learning curve is only going up to where? Is only going up to unit number 200. Learning is only going up to unit number 200, after which it ceases. So then the very first thing that I will do is to calculate the time of stability. Give us the time of stability. Because there is stabilization here, give us time of stability, which is a time of 200th unit. So this needs some form of expansion. We must expand this. Time of the 200th kitchen, what we shall do here, we shall come on top of y 200th. Is there somebody who can expand this for me? Tell me y first what minus y first what? Y first what minus y first what? Here to help you remember. And you guys will thank me after your exams. So y 200. So we have here y first 200 minus y first 189. Because we would want in this case to be left with the 200th unit. And then if that is the case, I will come and say, of course, first 200. So we use now the formula. So in this case here, we're using the formula. Remember, 24 is applicable to both. So you can come and put 24 here outside. And then you say first 200. So x is 200 here. 200 raised to 0.926. 200 raised to 0.926 minus 199. So this will be 199 raised to 0.926. I want to see everybody punching this in their calculators. The time of stability. 200 and 199, yes. The time of stability, according to Jogo, it is 15.0185 hours. Or 15.02. Normally for this kind of arrangement, the more the decimal places, the better. The more the decimal places, the better. If you can even do 4, that will be very good for us. You can even do 4. You can even do 4. So in this case here, they're telling me that time for the 200th unit, will be 15.0185. I hope everybody is able to see this. I hope everybody has been able to get this. So we are going to have, in this case here, our total time like this, total time. So we have here time for the first 200, time for first 200. So here use learning curve. So 200, so it will be 24 times 200 raised to 0.926. Actually, the first one here. 24. So the first 200 units, we have here 24 times 200 raised to that. So is there somebody who can give me this? Time for the first 200 units. So Chogo gives me 3243. 32.1345. Great. So all of us, I think you have lost. Most of you are not responding at all. Most of you are not responding at all. And then remember, we were given how many kitchens in total? How many kitchens were we given in total? How many kitchens were we given in total? The kitchens were given in total over 600. We have been able to account for the first 200. Now, in this case, here we have the balance, time for balance. Balance of 400 kitchens. So now remember, this comes after we have stabilized. So after we have stabilized, each kitchen will take this 15. Each kitchen will take that 15.018. No learning anymore. No learning further. So 400 times 15.0185. This will give me what figure, somebody here? 6,007.4. And therefore the total hours will be how many? Therefore the total hours will be how many? Therefore the total hours will be how many? You add the two now. 9,000 and something. 9250. 9250. 9250. 9250 point. 9250 point. Now, once you get this up to here, then you are a champion. 0.5345. 5345. Or even 53. Nobody can penalize you for this. So in this case here, this is correct. Then now what you need to do, pretty fast. What you need to do pretty fast, or rather, it's good. I confirm to you that this is correct. It is good. I confirm to you that this is correct. It is very good for me to confirm for you. Very good. Yeah, great. So this is it. So then when you check here, you can see number of hours, 92.47. They're getting 92.47 because of rounding off. But if you look at, actually even their method is normally a bad method because they use this average. They do so many things. Before they get this, like 32.43, we got 32.43 ourselves, and then we have 6,004. It's because of, you can see even here they took 15.01 instead of 16.02. Or 0.0185 like that. But now we've done a very good job. Then there we are. So the only thing that we're left now to do is this one here. Now where the cornered very many students, is here. Where the cornered very many students is here. This is where they cornered many students. Where they cornered many students in here. Where they cornered many students in here. You see now they gave us overheads. And then they told us overheads are here versus hours worked. And then they told us in this case here to come and use high-low method to analyze overheads. So remember, we use a high-low method to split overheads. Not. We use high-low method to split overheads into variable, the fixed, into variable and the fixed cost components. Equal to, we use high-low method to split overheads into variable stroke fixed cost components, stroke fixed cost components, stroke fixed cost components. So then what we shall do, we already have hours worked is our X. And then we have in this case here overhead costs. Overhead costs. So there are 4 of them, 9,300. We have in this case here 9,200. We have 9,400, and then we have 9,600. And the overhead 115,000, the first one. The second one in this case here is 113,600. 113,600. The third one is 116,000. 116,000. The fourth one is 116,800. 116,800. Please listen as you write yours there. So whenever we talk about overheads, high-low method, you select the lowest X value. So like now the very lowest X value is 9,200. You take it as a point. So this is what we call the lowest activity. But you look for it at X here. So again, highest. And the X highest is 9,600. So you pick this like that. So now this is the highest activity. Highest activity. So then once you have been able to do this, you come and form the high-low equation. How do you form the high-low equation? Remember, high-low equation is straight line. High-low equation is straight line. So high-low equation is straight line. And our straight line looks like this. Y equals A plus BX. So our high-low equation is straight line. It looks like this. Y equals A plus BX. So remember, this is your Y. This is your Y. So Y, let's pick the low or the high. You can start with any. Start with the high. So the Y for the high is 116,800 equals A plus BX. So B times X. X, of course, for the high is 9,600. This is high equation. High. And then we have the low. The low is here. The Y, you're substituting here. The Y is 113,600 equals A that we don't know plus 9,200. B times 9,200. B times 9,200. This is the low. Now reorganize your equations. You reorganize your simultaneous equations. Reorganize your simultaneous equations. Reorganize your simultaneous equations. So then what we have here, we have 116,800 equals A plus, this is 9,600B. Equation 2, we have 113,600 equals A plus 9,200B. So then you go ahead and do what? Here, subtract. You go ahead and subtract to eliminate A. So can somebody in this case here give me this subtracted value? So this minus this gives me what value? This minus this gives, you'll cut this and know this very easy. So this is the 400, right? 400 equals A disappears. This gives us, I think this is 400, 400B. So yeah, okay. The first one is 200. No. The first one, yeah, this minus this cannot be 200. 3,200. 3,200. And therefore B will be 3,200 divided by 400, which will end up being equal to what? Which will end up being equal to 8. 8. So B is 8. Then what do we do to get the value of A? What do we do to get the value of A? What do we do to get the value of A? To get the value of A, we'll come and substitute from equation 1. So this will be 116,800 equals to A plus 9,600 times B, which is 8. Therefore, A would be 116,800 minus 96 times 8. Because this crosses over, it becomes a minus. When this crosses over, it becomes a minus. So then my A will be equal to, Juliana tell me, 40,000. A is 40,000. So remember that A is fixed cost. So this will be fixed cost per month, 40,000. B is variable cost. Variable cost. So variable cost in this case here is 8 an hour. Because remember these were hours. B is variable cost. If you remember from the equation, we know that total cost equals fixed cost plus variable cost times what you X. So this V is variable cost per hour, and then fixed cost upon a monthly, a year. Because now there we have months, and the fixed cost given here is monthly. So then I'm through with the variable cost per hour, but I'm not through with fixed costs. Tell us that fixed cost must be absorbed. Fixed cost must be absorbed. Fixed cost must be absorbed. Fixed cost must be absorbed using labor hours. Fixed cost must be absorbed using labor hours. Fixed cost must be absorbed into units using labor hours. So then that means that we need what we call fixed overhead absorption rate. This right in the full. We call it fixed overheads absorption rate. Fixed overheads absorption rate, which will be the same as budgeted fixed overheads over budgeted hours. This right like that. Fixed overhead absorption rate will be budgeted fixed overheads over budgeted hours. Budgeted is the same as expected. Fixed overhead absorption rate will be budgeted fixed overheads over budgeted hours. So then come here and read this very well. So you can see here, they've told us, ladies and gentlemen, they have told us that HC normally works around 120 hours. Normally is the same as expected. 120,000 hours per year. 120 hours per year. So that means that this will be budgeted fixed overheads per annum, annual, because of course these are annual. Now what we have is budgeted fixed overheads here, this 40,000, but you see this is per month. So 40,000 per month. So to annualize them, multiply them by 12. And the budgeted hours, they have given us 120,000. I know it may look like big, but just give me this. Give me this fixed overhead absorption rate per hour. Fixed overhead absorption rate per hour. 40,000 per month times 12. It has to be annualized. Divided by budgeted hours, which must also be annual. So then this one here will give me what figure? You'll be able to follow, don't worry. Great Chogo is asking a very good question. Were we told that they are per month? It's because of this Chogo. Remember when you're analyzing them, you have this month, 1 month, 2 months. You know, like they're like average per month. Because these are months, Chogo. These are months. So then these will end up giving me what figure somebody there. We want to finish before we start. We only have 5 minutes actually. We only have 5 minutes. Please give me that figure, 40,000 times 12 over 120,000. They're giving me 4. They're giving me 4. 4 per hour now. 4 per hour. So then lastly, we have our cost statement. So cost statement for producing 600 kitchens. So cost statement, 600 kitchens. So then this one here will be, number one, I can see we have labor costs. Labor cost. Oh, I rubbed my hours. Those hours mlembene ngapi? So the total were 93 something. Those hours likuwa ngapi oye? Those hours likuwa ngapi? Ni rub zile hours kufanya 600 kitchens. Ni rub zote imagine. Zilikuwa 93 ama 92 something like that, 1,000. The one that you did for the first 200 and then the next 400. 9250, eh? 9250. I know you don't have the exact figure, but it's supposed to be having some decimals. It's supposed to be having some decimals, if I'm not wrong. 9250.5345. And then, of course, they've told me how much they are going to pay per hour. They've told me labor cost per hour. They've told me labor cost per hour is how much? They've told me labor cost per hour is 15. They told me this somewhere here. Labor cost per hour. Yeah, labor cost 15 per hour. So times 15. Please give me this figure. In terms of dollars, how much are we getting? In terms of dollars, how much are we getting there? In terms of dollars, how much are we getting there? It's 250.5345 times 15. In terms of dollars, how much are we getting there? So labor cost. Then we have variable overheads. Variable overheads, I can see it is 9250.5345 each hour is 8. Variable overhead is 8 each hour. Then we have fixed overheads, 9250.5345 times 4. Please give me all these figures very fast. So according to Juliana, the first one is 138,758. 138,758. Thank you very much. How about the variable overheads? Sorry for rushing you through, but I know you understand. And then again, remember in the evening, we have AMA. In the evening today at 6 p.m., we have AMA, the normal class. So are you able to give me this figure, ladies and gentlemen, please? 74,004. 74,004. So divide this by 3 by 1, or take this times 4. How much are we getting there? 37,002. 37,002. And now you can add everything. 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 So when you add everything, apart from rounding off errors, then you should be able to get this figure. Have you told the AFM students that we shall be late by just 3 minutes? Tell AFM students we shall be late, a little bit late by just 3 minutes. So it should be around this figure, 249, around there, 250,000. Because I saw they had a very big error there. I don't know if you'll be able to follow. Their analysis very well. The other question that I messed up a little bit, so it's good to clarify things, especially when they are still hot, when you have just remembered. Yeah. So for instance, we have here supervisors. We have in this case here plus. We have GE. We have GC, GC, and then we have X, GC versus X. And then what do we have here? GC versus X. What do we have here? So remember, this one here for GC, it is one visit, site visit, one visit, and then X. In this case here, we have got how many visits? X, I remember very well, we required 6 site visits, and then planners, the planners, one planning document. So this was one planning document, and then X is 5 planning documents. Now, this question was simply for the students here to fail, because you can see, like, for example, they have given us the total per year. So we have here total is 500. Total is 500 here for planner, for supervisor, and then planner, the total is supposed to be 350. So what they wanted, this examiner wanted the students to see, and I've never seen this kind of a question before. They wanted the students to know that apart from GCEX, we had the other products that this company was producing, which needed the supervisors and the planners. So that when it comes to apportionment, so we have others will be taking 500 minus this and this. So for example, the first apportionment, you've seen them doing there, the first cost that we have here, which is supervisory, is 90,000. So in this case here, we have a cost, we have 90,000 for supervisory. So in this case here now, in terms of the products GC and the EX, this is what they have done. So for GC, they took, in this case here, 1/500. 1/500 times 90,000. For EX, they took 6/500. Genius of an example, 6/500 times now 90,000. Like that. The same time now, we have other products. So you'll be able to follow that answer very well. You can also revisit it later. Thank you very much. See you in advanced financial management. Bye.